Hello, Integrated 1 students. So today we're going to be doing the second to last lesson on polyhedra and their properties. Just as a reminder, a polyhedron is any three-dimensional object whose faces, the outside of it, are made up of polygons. So this tea canister, for example, would be an example of like a square prism, maybe. So this is an example of a polyhedron. The first thing that we need to talk about is reflection symmetry. So I'm going to give you kind of a bunch of concepts and explain a few concepts and some definitions, and you'll use this video and the definitions and concepts to answer some of the questions in your assignment document. So the first is reflection symmetry. So if I draw a cube, what reflection symmetry means is where can you draw a plane in this cube so that half of the cube looks exactly like the other half. So here's an example. I could draw a plane in this cube right down the middle of it, just like this. And I'll shade this in so we can kind of see it a little better. But this plane in the cube, looking at this plane, either half of the plane, so the left side of the cube and the right side of the cube, look exactly the same. Here is another plane, reflection plane in this cube. So if we look at the part above this plane and below this plane, they're exactly the same. So a shape has reflection symmetry. If you could draw a plane like this, like the red or blue plane in the middle of the shape, and have half of the shape look the exact same as the other half on the other side of the plane, just like with this cube and the two planes that I drew. So the blue and the red plane are called symmetry planes. So a shape has reflection symmetry around its symmetry planes. So that red and the blue plane that I drew are called symmetry planes. And just as a reminder from last class, this is called an oblique drawing. So you're going to be asked to draw an oblique drawing of some shapes. And all that means is to draw like a see-through figure so that you can see the back edges. Like in this cube, you can see all the edges of the cube. This is an oblique drawing. Another kind of symmetry that you're going to be answering questions about is rotational symmetry. And what rotational symmetry is let me draw another cube. Rotational symmetry is like if you took a red or a line and you drew a line straight through this cube, straight from top through bottom. Rotational symmetry are lines like this where you could spin the cube around that line and eventually have it look exactly the same. So for example, this tea canister, I can rotate it 90 degrees like that and have it look exactly the same. I can rotate it 180 degrees and have it look exactly the same. And I can also rotate it 270 degrees and have it look exactly the same. And then if I rotate it one more time, we're at 360 degrees. So this tea canister, this square prism, has 3 different rotational symmetries: 90 degrees, 180 degrees, and 270 degrees. There's 3 different ways I can rotate it without doing a full circle where the shape will look exactly the same. So that's rotational symmetry. And the line that you're spinning the shape around, like for example in this cube, or in the case of the tea canister, the line would go straight through the middle of this circle right here and come out the same place on the bottom of the shape. That's the axis of symmetry. It's the line that you're spinning the shape around or rotating the shape around to have it look exactly the same when you spin it through each of its rotational symmetries. The last thing we need to talk about is rigid shapes. A rigid shape is a shape that you can push and have it not move without breaking one of the sides. So for example, here's a cube. If you apply a force to the top of this cube right here, you could make it bend so that it kind of looks like this, kind of squished over to the side. And you could do that without breaking any of the sides of the cube. That's not a very good drawing. But you could. It would change the angles of the cube, but it wouldn't break any of the sides of the cube. So some shapes are not rigid shapes. You can push on the top of it or push on the bottom of it and squish the shape. You could change the angles in the shape, but you could do that. You could kind of squish the shape without breaking any of the sides. Triangles, if we're talking about polygons, are a shape that you cannot squish without breaking some of the sides. So if I have this triangle and I apply a force or I push the top, there's no way for me to change the shape of this triangle without breaking one of the sides. So when you're thinking about rigid shapes, that's one of the last questions that you have to answer. Think about which of these polyhedra, these three-dimensional figures, you could push and like squish them so that they look like a different shape without breaking any of the sides. If you cannot squish the shape into a different shape without breaking one of the sides, then it is a rigid shape.